The psychology of human memory. Psychological studies have revealed several types of memory system have a role to play in human cognition, each with its own specialized function and its own properties. Central properties that distinguish these types of memory are the capacity or size of the store, the decay time or the time for which items will persist before being forgotten, and the time it takes to recall or access items. Three classes of memory that psychologists have studied extensively are sensory memory, short-term or working memory, and long-term memory. The diagram, extracted from the Model Human Processor of Card, Moran, and Newell, 1983, summarizes the characteristics of these memories and the relationships between them. Although the figure only shows sensory stores for the visual and acoustic senses, specialized memories exist for the other senses as well. Sensory memory. The first type of memory is responsible for recording information as it comes from our senses prior to processing by other cognitive mechanisms. This so-called sensory memory acts as a kind of buffer store between the sensory organs and other forms of memory. In fact, the sensory memory is not a single entity, but a series of specialized stores, one for each of our senses. Thus, images perceived by our eyes are retained briefly in the visual or iconic memory, and sounds perceived by our ears are stored in the acoustic or echoic memory. These memories store images of what is perceived for a short period of time, and can be thought of as being continually overwritten as new sense data arrives. In fact, there are several different sensory memories, one for each of the senses, each having a different capacity and decay time, and storing images specific to a single sense. Short-term, or working memory. The second form of memory is referred to as either short-term memory or working memory, and can be thought of as a kind of scratch pad in which information that is the current focus of our conscious attention is stored. The short-term memory typically stores sensory data from the sensory memories and other short-term information that is needed as mental tasks are carried out. Typically, our senses are bombarded by a vast amount of information about the external environment, and therefore, a large volume of sensory stimuli enters the sensory memories. However, we choose to pay attention to only a small amount of this, and this attentional focus allows only a part of our sensory experience to be passed on to working memory. In addition to processing sensory experiences, working memory also serves as a kind of scratch pad in which thoughts are stored while they are our focus of attention. For example, if you wish to multiply 39 by 8, it is necessary to remember these two numbers. Multiply 9 by 8 to produce an intermediate result. Remember the 30 and 8, and multiply them together, producing another intermediate result. The two intermediate results must then be remembered and added together, a process that involves further remembering of small amounts of information which are stored for short periods of time and then discarded. Working memory has only a very limited capacity. Studies have shown that it typically holds between 5 and 9 items, though what counts as an item is by no means fixed. Items persist in working memory for a relatively short time, from a matter of a few milliseconds up to tens of seconds. This means that working memory is a very limited resource, and if tasks make excessive demands on it, then errors are likely to result. Long-term memory. The third kind of memory is referred to as long-term memory, and is an effectively permanent and infinitely large store for semantically linked information. A number of distinctions between different forms of long-term memory have proved useful in the study of memory by psychologists. The subtitles of these different classes of long-term memory and the theories about how they function are not really relevant to this module, but it is worth noting that a variety of different kinds of information are stored in long-term memory. These include facts about the world, computers, and other devices we use, and tasks we carry out, sometimes referred to as semantic memory. Things that have happened in the past, autobiographical memory. things to do in the future, prospective memory. The processes by which we are able to remember items that are stored in long-term memory are complex and are the subject of much psychological research. However, a factor that greatly affects our ability to remember something is its familiarity, both in terms of its meaningfulness and the frequency with which items have been remembered in the past. This is why the use of graphical icons in a user interface can aid usability. The more meaningful a graphical element or a name appears to be, the more likely its meaning is to be remembered. For this reason, the meaning of menu items like print and icons like are more likely to be remembered than Control X or F4. In addition, in a given situation, we are more likely to successfully recall a fact or piece of information that we have recalled often in the recent past than something that is only occasionally required. Knowledge in the head and knowledge in the world. Memory research has shown that humans are far better at recognizing material presented to them than they are at recalling material from memory. One of the difficulties with text-based command line user interfaces, as the Unix example above shows, is that the user interface affords very few opportunities for recognition and relies almost totally on the user being able to recall the relevant commands from memory. Graphical user interfaces, on the other hand, make use of menus, icons, and similar devices to provide the user with on-screen representations of the commands that are available. The mental act of recalling how to carry out a particular function is therefore transformed into the rather less demanding task of recognizing the visual representation of a command. In general, we are able to combine information we recognize in the environment with that recalled from memory in deciding how to act. Experimental research in HCI suggests this is precisely the way people make use of menus and similar visual interface features. Even experienced users of a system have a very poor recollection of what menu items appear where in an interface, how they're labeled, and so on. What this means is that, in order to be proficient at using a computer program, it is not necessary to remember precisely how the user interface works. It appears that, instead, users decide what action to take largely on the basis of matching options and functions displayed on the screen, for example, as menu items and headings with their current goals and intentions. For example, if the user wishes to save the current document, they may well look for items that are relevant to this goal. Of the options that are available, the File menu tab will be recognized as the most relevant, leading the user to pull down that menu. Once the menu appears, a number of options appear, allowing the user a further opportunity for recognizing the one that is most relevant, in this case, print. Donald Norman, C. Norman, 1988-1990, has discussed the difference between recall and recognition in terms of the location of knowledge as being in the head or in the world. What this means is that our actions are often governed by bringing together information that we recall from memory and information that is present in the external world. In everyday life, we frequently arrange our environment so as to place important information in the world where it is less susceptible to being forgotten or misremembered. Familiar examples of this are when we write notes to ourselves or lists of things to do at a later time, thus offloading the responsibility for storing them. As designers of interactive systems, it is possible to achieve similar effects by placing important information about how a system works in their user interface, rather than relying on the users remembering it. Implications for a user interface design. From the discussion above, it should be clear that an understanding of how human memory works is very useful in designing human-computer interfaces. Some key points to bear in mind when designing user interfaces are: reduce working memory load. Try to minimize situations where the user must remember temporary information. For example, if the user needs to make use of selections made earlier in a dialogue, then the choices made should be displayed so the user doesn't have to remember them. Recognition of interface elements presented to the user is far more effective than requiring the user to recall how to use a system. Therefore, where possible, put the knowledge about how a system should be used into the user interface. Graphical user interfaces typically require far less mental effort than text-based ones, as they put more knowledge and information in their user interface. This allows the user to recognize what is in the interface, rather than having to recall facts from their memory. The use of meaningful and easy-to-understand icons, text labels, and menu items is a way to do this, and therefore reduces the burden on their user's memory. User interfaces, in which commands work in a consistent way, reduce memory demands on the user. For instance, in Microsoft Word, the tab key inserts a tab character most of the time. When the cursor is inside a table, the tab key moves the cursor onto the next box in the table. The designers have therefore forced their users to remember and recall an extra item from memory, the rule that governs how a tab behaves inside a table.